Cool. So hi, my name's Williamson. I'm a final year student at CIT studying software development. And as part of that degree, I had to do an undergraduate project, and I did it on the evaluation of a microservice first development approach. So just for the scope of this, first I'll give an introduction: what are microservices, how do DevOps play into microservices, the motivation and objectives of this project, quickly look at the application architecture and design, the case study applied, design patterns used, and the solution architecture, and finish up with the conclusions, which are the lessons learned and best practices. So microservices, it's an evolution in software development that shifts away from monolithic design. So for those, what monolithic design is, it's your single runtime or say service-oriented project with a enterprise service event bus. So there's a lot of issues with this, particularly scalability, flexibility, continuous integration, and large teams. So to solve this, microservices have come. They're small independent services that capture a single responsibility. These can be managed, scaled, tested, and deployed independently. And these services are built using domain-driven design. So domain-driven design focuses more on capturing the business logic and the business domains, in a creative sort of integration between technical people and domain experts. So moving on, microservices have largely been made viable due to advances in dev operations. So things like the accidental complexity that would be introduced normally when developing a very large-scale enterprise application, this complexity gets moved on to automation and operation. So microservices benefit a lot from container technology such as Docker, and this workflow can be managed by dev operation teams, which do a lot better than software. So the motivation for the project. So typically an organization would start with an existing code base, which would be their monolith, and now they are given the task of splitting this up into a range of microservices. So there's an issue here. There's a lack of experience reports and best practices, but similarly, there is a similar lack of best practices for a microservice first development approach, and that is the focus of the project. So just moving on to the case study that this was applied to, an appliance maintenance and management system. So this was aimed towards property manager firms, property management firms. The amount of private rented households has increased by 10% between 1991 and 2011. By law, they need the minimum kind of 4 kitchen appliances that everyone needs to exist. So it sort of allows for the maintenance of these appliances, scheduling that, and just the management of the kind of entire business. So just to give some foresight onto the solution developed. So some of the microservice design patterns applied. So we have service instance per container. So this was done with Docker. So every service exists within its own Docker container. Externalized configuration. So this is a centralized config server with some sort of remote repository such as Git to allow configuration for individual services to be changed during runtime, so you don't need to start up a new build if there's some sort of configuration change needed. Client-side discovery. So every service would register with a central service discovery server. This gives benefits such as load balancing and logical addressing. The API gateway and backend for front end. The idea here is every application, public API device that interacts with your application would require its own gateway into your actual microservices backend, which would allow you to customize your API for that platform towards the user experience required for it. Circuit breaker. So the idea here is for any inter-service communication, whatever communication protocols you're using, that you can manage caching, thread pools, etc., timeouts. And this is all done at the configuration layer. Database per service to have better DAML design and better recognition of domain models. And access tokens, so this applies to your application access, be it different services authorizing against each other, or user authentication, which was implemented with JWT. So just the architecture diagram here. So the domain services are where these services actually encapsulate the business logic of the solution. So an example might be the user authentication service, which can I move or I'm stuck? Oh. So the user authentication service would manage like registration, user logging in, token refreshes, etc. The property appliance would be a specific, say, the appliance might be a brand fridge that you buy in Harvey Norman, and the property appliance is like an instance of that. So these services would capture any business logic associated with that domain. So each one of these services exists within a Docker container, and then there's the discovery service, which they all register against and can communicate, as previously mentioned, through logical addresses, and it handles load balancing. The Android Edge service in the middle there as well, which is also the API gateway for the Android client, the centralized config server, and lastly we have these over here. We have RabbitMQ, a server-side event stream aggregator, and a HTTP metrics dashboard. So this kind of integrates into the circuit breaker pattern. So all metrics gathered from your inter-service communication can be exposed and visualized through the metrics dashboard in order to see how reliable your system is. So I think I have some examples of that there now. So if I just move over here, so this is an example of the service discovery. It's a bit large, but so this is done with Eureka, a Netflix project, and you can see all the different services registered here. If they're down, you'll get a notification, etc. There's nothing running at the moment. But this is an example of the history stream. So these gather metrics on all the different service calls. So I'll just try to do something here. Okay, so there should be a bit more traffic now. I might need to refresh. Yeah, so you can see there's different calls going off there and get kind of metrics data off that. Back on to, oh sorry. So, and here's an example sort of flow for a particular use case, which is accepting a pending repair report. So just if there's, say, a fault with an appliance, the property manager could send off pending repair report, and then that would be pending, and it would need to be accepted, say, by an organization that handled the maintenance of a particular appliance. So I'll just go over that quickly. So the request comes in on the Android Edge service. This looks at the discovery service to get the physical address of the service in question. So it goes to the pending repair report service, and this particular piece of logic requires communication with the diagnostic request and repair report service. So that then communicates with them, and all the metrics gathered from that are published to RabbitMQ, which is then exposed through a HTTP endpoint on the server-side event stream aggregator. So some lessons learned, design issues. Typically this can be summed up as how big should your microservices be. Typically there was a poor knowledge of the domain of a sort of property management appliance system. So the initial services were rather large. There was kind of poor bounded context between different domains. In particular, enumerates for domain relationships cause inconsistency. So there was two particular services that sort of related, instead of using a foreign key, they related with an enum type. And the issue here was that if you made a change on one service and then you wanted to, if you made a change on one service, the relationship was not as resilient now, because every client application that also implemented that enumerate, they would all need to be updated. It causes code sharing, which is an anti-pattern towards microservices, and your system is not resilient. So similar with resiliency issues, so particularly composite UIs on the client side, you have to develop your clients with the idea of none of your services being up, especially with composite UIs. They need to be resilient. Netflix is a good example of this. If their services handling, say, the search function are down, the search bar won't actually appear on their client applications. So lastly, support for Docker Compose for orchestrating these services is very poor at the moment for AWS, Bluemix, and Google Cloud Platform. And some of the lessons learned, so as previously mentioned, develop your client applications with mock services before attempting your microservice implementation. This helps domain experts visualize any issues that were introduced, and it allows you to build better services as you've kind of a knowledge of the workflow and the business logic a bit better. Avoid logic that affects the state of multiple domains. Complex solutions will need to be introduced if too many domains need to be updated on a particular call. Use of in-memory databases helps enforce the database per service pattern. Resiliency, REST calls, and any other communication protocols being used should have fallbacks. They should be fault tolerant. No service should go down if a service it kind of depends on is down. Containers restart an application failure, and they should fail fast to give more uptime, make the system a bit more resilient. And lastly, you want to monitor inter-service communication metrics, use heavy use of containerization, as well as things such as logging aggregation, etc. So that's it. Thanks. And any questions? Yeah.
Was your project more concerned in the how rather than if you should? Given this particular domain, it strikes me that it may be a bit overcomplicated for the problem you're trying to solve.
Yeah, as I mentioned, domain expertise in the area. It was more just looking at a case study to apply this problem to, as opposed to actually come up with some sort of prototype solution that could solve the problem. Yep.
Did you solve the enumerate problem, or?
Currently exists in the demo.
Okay, and so would it have been, do you think that your service should have actually maybe been bigger? I know you were going the other way, it should be smaller.
Definitely,
so
sorry.
Yeah, there seems to be a lot of services there.
Yeah, certainly some domain capturing was poor. And yes, some domains were captured poorly. If I had more domain expertise of the area, they would have been better, I'd imagine, or if I had an actual domain expert. As domain-driven design is a very big part of actually figuring out the boundaries for your services. Without that, it can be a bit poor at times. But I think it helped ultimately in kind of showing some of the problems that do occur if domains are captured poorly and you're scaling this massive application with a lot of services. What are the problems that are going to happen?
Yeah, no, it's a really useful project to try and investigate those issues. You're hardly going to be a domain expert in that overnight. The only other thing was, did you find it difficult to debug problem scenarios compared to a monolith?
Definitely when it came to the use of Docker as well, when you have, if you don't have a good integration testing environment set up, it's very hard to debug Docker containers. Maybe there's some tool I could have used, but I didn't find anything suitable. So it's like if you're trying to debug two services and you're also running on containers, if you don't have different configuration for them to work outside of the containers, etc. Yeah, it can be difficult to debug.
Was your tech stack all the same? Was it all like Java throughout, or did you try experiment with?
I had a look at, so there's a Netflix project called Prana, which is a sidecar, so you can use any different implementation, just implement a few REST calls and it'll integrate with the system. So I had a look at the technology behind that, and I wanted to try it with using, what is it? It's Groovy. It's done by Pivotal as well. Sorry, I can't remember the name of the. It kind of mimics Ruby on Rails kind of infrastructure. It's built on Spring. Grails, thanks. So I tried doing it with Grails, but I had just massive issues with running projects for some reason, some JDK thing. I think it needed an older version of JDK that isn't available publicly anymore, so I had to drop it. Yep.
More there. Did you use Rabbit between services, or was it REST you were using?
I was using REST between services. Yeah, cool, thanks.